This question is from GATE 2017, Mechanical Engineering Paper Set 1, question number 47. For an inline slider crank mechanism, the length of the crank and connecting rod are 3 meter and 4 meter respectively. At the instant when the connecting rod is perpendicular to the crank, if the velocity of the slider is 1 meter per second, the magnitude of angular velocity up to 3 decimal points accuracy of the crank is dash radian per second. Let's find out. Let me draw a sketch to represent this crank slider mechanism given here. It's given that at a particular moment, the angle between crank and connecting rod is 90 degrees. The slider moves towards the right side with a velocity of 1 meter per second. So we can write velocity of slider is 1 meter per second. And we are asked to find out angular velocity of crank. So if slider is moving in this direction, definitely the angular velocity will be clockwise for the crank. Let's name these points. This point is A, where the crank meets the support. This point is C and this point is B. Let's connect A and B together to form a triangle here. And triangle ABC clearly has a right angle at C. Now let this angle be alpha, that is crank angle, and this angle be theta. Now in order to find out omega, we can interpret the direction of velocity at point C. So if we manage to find out velocity of point C in this direction along BC, we can find angular velocity of the crank rod, because we know that if let's say this green vector we name as VC, VC can be given as omega into the length of crank rod, which we take as R. So omega into this distance R, omega R, can give us the velocity of point C along BC, because BC is perpendicular to the crank rod. So if we manage to find VC, we can find omega. Omega will be simply VC by R. And R we already know, length of crank rod, which is 3 meter. We need to find VC in meter per second now. So we know that velocity of point C in this direction, that is parallel to this velocity vector, which represents the velocity of slider. Magnitude of velocity vector in this direction at point C will be 1 meter per second itself, because BC is a continuous piece of rod, and therefore all the points on this rod are moving with the same linear velocity. So VC can be then easily found out as component of 1 meter per second. VC can also be written as 1 meter per second velocity into cos component of it. So this angle is theta, because these are two parallel lines and the alternate angles will be equal, which these parallel lines are making with the transversal BC. So this is also theta, this is also theta. Therefore, VC will be equal to 1 into cos theta. Cos theta can be found out easily in this triangle ABC. So in triangle ABC, we have cos theta is equal to adjacent side upon the hypotenuse side. So adjacent side is BC and hypotenuse side is AB. We know the value of BC is 4 meter. And we can find out AB as the hypotenuse side using Pythagoras theorem. So it is under root 4 square plus 3 square, which is 4 by 5. So VC here is cos theta, that is 4 by 5. And then we can put VC over here to get omega. Omega will be equal to 4 upon 5 into 3. That is 4 by 15, gives us the value 0.26 recurring. And can be written as 0.267 radians per second. So let's go back and mark the correct option. So options are really confusing, and our correct option is option C, having the value 0.267 radians per second. To learn more about velocity analysis in slider crank mechanism, you can refer to the NPTEL video lecture 24, Analytical Velocity Analysis 1, from the course Kinematics of Mechanisms and Machines. The course is by Professor Anirvan Dasgupta. He is from Department of Mechanical Engineering of IIT Kharagpur. I hope this solution will help you clear your doubt. Thank you.